This presentation is about OAM spec updates for management and security aspects. I'm Yuval Litkin, Distinguished Architect for Mellanox.
And I'm Ben Wei. I'm Assistant Software Engineer at Facebook.
This presentation talks about a roadmap of leading OAM management into converged protocols and methods. The guideline is to direct all of us to standard-based management protocol in order to save the need for vendor-defined software and BMC firmware development and maintenance to support evolution of those. The transition to standard-based management protocol is not instead and is entirely complementary to other efforts such as OAM tool, UBB, and DC-SCM. And this roadmap is not expected to be adopted immediately. It's a roadmap, therefore, the idea is that migration will be done over time. Some of the features require design changes to the system and the acceleration modules. Where we are right now, OCP OAI defines the OAM tools, DC-SCM, and OCP also defines OpenBMC. At the same time, DMTF as a standard body defines the management and transport protocols like MCTP, SPDM for security, PLDM for monitoring and control and firmware update, Redfish for remote management, and RDE for remote management using Redfish protocol of integrated devices. OAM management requirements facing standard-based methods assume that using PCIe devices like OAI cards, these cards already have existing interfaces such as SMBus, PCIe, sometimes JTAG, and others, and therefore there is no intention to require new connectivity. The connectors are already there, but only using transport protocols using those interfaces. MCTP-based transport protocols, which can use both PCIe and SMBus, are intended to eventually replace the use of IPMI over IPMB, and allowing also to do management and security protocols, especially talking about PLDM both for monitoring and control, firmware update, SPDM for security, Redfish, and others. And all of these are going to be supported, some of which are already supported through OpenBMC. When talking about the existing interfaces, if we look carefully, then SMBus allows using MCTP over SMBus as defined in DMTF Spec DSP 237. The benefit of using this interface is, of course, it's already available, but it requires slight modification of supporting multi-master operating mode, while today OAI defines that interface to be slave only on the module. Also, this interface is relatively slow. We are talking about the order of hundreds of kilobits per second up to 1 megabits per second and not more than that. At the other end, we have the PCIe bus, which we can use using MCTP over PCIe VDMs, which is defined in DMTF document DSP 238. It's by far faster, orders of magnitude more faster. But at the same time, it does require some supporting hardware to be existing on the system and on the OEM hardware. And it's more complex to implement because of these added complexities. And there are some limitations on some platforms, configurations, talking about multi-socket platforms and stuff like that. Not every chipset today is already supporting MCTP over PCIe VDMs. So therefore, it may take some time for all the vendors to apply support for that.
Right. So from the management point of view, so some of the key areas where we identified are, so these are the features that OpenBMC will support, which is one, asset management. So these are stuff like reading the flow, reading the asset tag, the manufacturing information. The operational parameters, BMC wants to be able to read or perhaps even set the current operational parameters of any device. Number three is the state and health monitoring. Any sensors, any state sensors, what are the threshold, for example, for BMC to detect if we need to log any events where the threshold was exceeded. And lastly, one important feature is the firmware update. We want to be able to support a standardized way to update any device firmware we have through BMC. Additionally, we want to be able to update any configurations through BMC through a standard method. Okay, turning back to you, Yuval.
The transition from IPMI sensors to use PLDM semantics and RDE allows for more information to be exposed. For example, instead of having a single threshold for temperature sensor, you can have multiple thresholds for the same sensor, reflecting different severity levels. You can have multiple thresholds also for other sensors like power consumption and voltage. In addition, you can reflect health, you can reflect parametric sensors like clock speed and operational profile. When devices have multiple configuration operational mode, you can reflect that as well. Vendor-defined thresholds are very important sometimes when different vendors design their own modules, and each and every vendor has its own design time guidelines of what's okay and what's not okay for some parameters, be it ambient temperature, be it actual silicon temperature, be it other critical parameters like too fast clock speed, etc. And for those, the vendor can define for each and every sensor what's the warning, which is still okay, but that's the end of the recommended operational range. Critical, which says still functional, but do not use that value for extended duration of time because you may accumulate degradation in performance. Or fatal, which means stop that device immediately. Extensive reporting of the module operational state and all the interfaces using TBD, Redfish schema TBD, because that schema does not exist yet, and definitely this is a call for working closely with DMTF in order to create such a schema, will allow us to model the accelerator module in Redfish terminology such that everyone will know what to expect and what are the required sensors and required knobs that should be managed on such a module. In terms of firmware update, not only host-based vendor-specific tools are the right and only way to perform firmware update. If introduction of support for DSP267 is in place, then there will be standard method to perform firmware update, which is vendor agnostic in terms of how to do that. And once supported, the BMC can perform firmware update on supporting devices without need for any vendor-specific tools or even vendor-specific driver within the BMC. Using DSP267 for PLDM for firmware update does allow for full support for secure firmware update as well, because the root of trust for the update is part of the hardware of the module being updated.
Okay, on the state and health check side, so also we recommend using a standard DMTF ESP0248, which specifies the PODM for platform monitoring and control. And what this does is it provides a standardized way for BMC to discover and detect sensors and threshold and flow on any device and across vendors. Meaning we don't need to use any vendor unique commands, or we don't need prior knowledge of the sensor presence. And also what important on this is it provides a standard way for BMC to discover the threshold associated with each sensors. So this is important because then earlier, as Yvonne mentioned, there's a critical fatal stage. So this allows BMC to monitor these events and log accordingly and take appropriate actions. So in addition, the flow can also be accessed directly via I2C bus to EEPROM. So advantage for this is you don't need to have a firmware running on device for BMC to access the full information. So these are like manufacturing information, manufacturing date, for example. Okay, next, please. And on the OpenBMC utilities for OAM, currently we have a background daemon that monitors system events, such as sensor information, and actually it will do the sensor discovery, and then it will monitor sensor reading and log any events. Additionally, we provide command line utilities for power control, the firmware version check, and firmware update through the PODM that Yvonne mentioned. And also, OpenBMC provides command line utilities for flow and manual sensor read. Also, we have a PODM utility for debug purpose, so user can send any PODM commands to manually check sensor information, the flow data, and to manually update firmware. Okay, next slide, please. So our call to action is please join the OCP server and OAI sub-project and share feedback. So today we present our proposal for the spec, and we'd love to hear from you on any feedback you have. And please follow the infrastructure standard defined by DMTF, Redfish, and PMCI so that we have a standard management interface. And additionally, we'll provide this additional URLs for if you need any additional information. Okay, thank you very much.
Thank you very much for being with us. Does anyone have any question that you would like to be answered online? If no, then we appreciate your time and thank you very much.
Great. Yeah, thank you very much.